Okay, so we're going to go through some questions about polymers. Firstly, we start off really simple question. It talks about polyesters produced when monomers join together, and it says lose a small molecule. So in this first one, all we're trying to think of is a small molecule that can be lost. If you can't remember, it might help you to think back about what type of polymerization it is, and it's condensation polymerization. So if you can't remember, it might be worth thinking about what you do know about it, and then from condensation you can probably quite easily get the answer. Second question, we've got to complete the structure of the polymer. Now this is addition polymerization, and it's worth just looking at their diagram and picking up some hints. So I think this is a hint, and I think this is a hint. And then what we try and do is we try and use their hints in their diagram to help us with our diagram. So we're going to be thinking, what are we going to put here? And what are we going to put here? And then the rest of it should be fairly straightforward. The next one is a weird question. So it says, question 2, name the monomer used to form polychloroethene. And again, I've seen people do this question wrong. So this tells us it's a polymer, and therefore the monomer should be fairly easy to figure out. Another example would be polyethene. Now we know that ethene is a monomer and it's used to make polyethene. So then again, by using what we do know, we can apply it to something that we don't know. We probably haven't done chloroethene before, but we can apply it to that situation. The next one is a reverse of the previous question. So this time we've got part of the monomer and part of the polymer. It's already given us something, so it's already given us that N, so we can't use that to get a mark. But then that gives us a clue about what's going to go there. It hasn't drawn the bonds in between the carbons, so that's probably going to be our second and our third mark. And it's always worth looking at the number of marks to judge how many you're going to get. So we can probably say 1, 2, 3. We don't need to think about anything else. Next one, it says polychloroethene is the only product. And notice what I'm trying to do, I'm always highlighting things. It just helps me to understand the question. What type of polymer is polychloroethene? Right. It's not a very clear question. So we've got two types of polymers, addition and condensation. So we need to choose which one it is. Again, a lot of these questions, they look more complicated than they are, and that's something not to be put off by. So this one, it says ethane diol reacts with butane dioic acid to produce a polyester, and again a small molecule. We get the structure of ethane diol, and it says name the functional group present. Well, that's just straightforward knowledge. All we've got to do is use the diagram. So we have a look at the diagram, and we've got to choose the functional group in there. Next one, tick box 1. So it shows the formula of butane dioic acid. And which formula represents the carboxylic acid functional group? Well, we probably just know this. But what you could do is you could go through process of elimination. Well, you see that and that in lots and lots of other molecules. So if I draw an alkane like butane, then we can see CH2 and CH22 in there, and we know that's not a carboxylic acid. It could be maybe this one, maybe you do need a CH2 beforehand, but then if we think about our simplest carboxylic acid, methanoic acid, it doesn't have that. This would be implying that the simplest carboxylic acid is ethanoic acid. The next one, this is getting harder now, so it says shows the structural part of the polyester. Complete the box in figure 4. So what we're having to do is add in bonds. Now it is providing us some hints. There's a bit of a hint here, and there's probably a bit of a hint here as well. So we've got to do this bond, and this bond, and this bond. Now if you can't remember this is actually the ester bond here, and the ester functional group. You might not remember it, so what you can do again is try and think back to what you do know. So I always want carbon to form 4 bonds. That's how it functions when it's covalently bonding. Oxygen will always form 2, and hydrogen will always form 1. Sometimes it helps to draw these out fully, so what you could do underneath here, well actually that carbon, this one here, is actually going to look like that, and it's already formed 3 bonds and we need it to form 4. This oxygen then, you can figure it out, and then this oxygen, well it's only going to be bonded to one thing, and we just need to remember what type of bond forms when you need 2 bonds, where it only bonds to one thing. Then we've got a question about starch, proteins and DNA. It says they're naturally occurring polymers. So name the monomers from which starch and proteins are formed. Again, the way it's worded is tricky, but all we've got to do is think back and right, what is starch made from? What is protein made from? We could even think back to another topic, B2. When we break down proteins, what's the product? When we break down starch, what's the product from digestion? Next, it says describe the structure of DNA. And for this one, it's only worth 2 marks. There's quite a lot we could say, and therefore it's probably quite hard to figure out where the marks are going to be awarded. So what we're going to do before we answer this question is think about how much we can fit in. Now if we make 2 points, we might miss out on some of the marks. Maybe our point isn't going to be included, so I'd be wanting to think about all the things I know about DNA, brainstorming it, and then trying to get them all in my answer. So something like double helix, 2 chains, the monomer in DNA, and this is about, it's worth going back to the question, this is about polymers, so we want to refer back to it. So the monomer is called a nucleotide. What else do we know? Well, there's 4 different bases. What else do we know? Well, a nucleotide consists of 3 parts: the base, the phosphate and the sugar. So we can combine all these things into an answer. It doesn't matter that it's only worth 2 marks. There's actually more that we could write about it, and if we have time, it's worthwhile doing that. Okay, the more exam practice you do, the more you notice the questions that keep repeating. So this one, we've got ethene, polyethene. All we've got to do is draw the bonds. This time it doesn't want anything else apart from bonds, it's already got the ends. So all we've got to do are the bonds. These aren't the bonds, I'm just showing you where you draw them. And this is a really important point about exam papers. Practice really does help, because you begin to see what they like to ask time and time again. Then we get a question which looks more difficult. Okay, so it says polyesters are made by a different method of polymerization, and it's got an example of it there, and it says compare the polymerization reaction used to produce polyethylene with the polymerization reaction to produce a polyester. This one, and you'll see from over the page, is worth 4 marks. Now, first thing it says, it doesn't tell us the name of the type of polymerization, so what I'd almost do is make a little table as a plan. I'm just going to write it here, but you'd probably write it to one side. So we've got polyester and polyethylene. Well, polyethylene's drawn above, and if we remember back, that's called addition polymerization, and therefore we just need to think of what's the other type of polymerization we've done about. We need to think about the product. So if we look at this one, it's only one product, and again I'm using this and this for help. If I look here, we're getting 2 products. We're getting this large molecule polymer, and we're also getting some water. So I'd be thinking 2 products, and I'd maybe write down what they are. I'd be looking at what we start with. So polyethylene, if we've done this right, starts with this molecule, which is an alkene, and then we can look at our equation to figure out what our polyester starts as. And I just keep on doing that. I'd try and compare as much as possible, but essentially we're going to hopefully get 6 things written down there, 6 facts about our 2 types of polymer. So if we've got 3 about each, we should be able to get our 4 marks. Then we get another little question about polymers. Okay, so it says PVC is non-biodegradable. Give one problem caused by non-biodegradable polymers. What we've got to do here is be specific. So what you don't want to do in science is write in general terms like, oh, it's a pollutant, for example. Whenever you're answering small questions like this, we want to try and be really specific about what problems it's going to cause. And then, last couple of parts of this, we get figure 1 shows a short section of a PVC molecule. Right, okay, PVC is produced from a monomer that contains 2 carbon atoms. Complete the structure of the monomer. This time, all I've done is they've given us the 2 carbons. So, I mean, you've seen quite a few of these now. It's obviously a question they like to ask. We're going to draw something in here, something in here, something in here, something in here, something in here. Because it's a monomer, I would always write that N there. I don't think it would be assessed in this question, but I think it's always worth writing in, and it's just getting used to good practice. And then final one, so it shows us 3 monomers. Okay, so we've got monomer A, and it's showing us the functional group within a box. So we've got that one, and this one. It already gives us monomer B, and then it wants the functional group of monomer A and monomer C. So what I'd be thinking here is, what functional groups have we learned about? Well, alkenes, alcohols, but that are given, carboxylic acids, and esters. Hopefully you'll know one of those, and then it's a process of elimination, and that's, again, it's a way of linking it to what we've learned elsewhere. I'm always trying to link ideas and think, you know, if I didn't know, how could I work it out? And I can look at this and think, right, I probably know that one, and I probably know this one, so therefore this one must be the other thing. Okay, I'll do.